Solving quadratics by completing the square. So we have the general form x plus y bracket to the power of 2, which is our perfect square binomial. When we expand this, we will get the perfect square trinomial, which is x squared plus 2xy plus y squared. So when we solve for x, one side should be a perfect square, and then we take the square root of both sides, and then we solve for the value of x. Let's say, for example, we have x squared equals 64. So when we find the value of x, we take the square root of both sides. So this will be x equals plus minus 8. When you take the square root, you must consider the positive and negative answers. That is because positive 8 squaring it would give us back 64, and negative 8, when you square this, would also give you 64. That is why you have to take the positive or the negative of the value. But what happens if you don't have a perfect square on one side? For you to be able to solve a quadratic, if it's not perfect square, is to make it perfect by doing the process of completing the square. So let's take, for example, x plus 6 as a perfect square binomial. So when we expand this, so that you would understand why we do completing the square, or how we do completing the square, is when we expand a perfect square binomial, if you would notice, when we expand this, first is we square the first term. So that is x squared. The second step, we copy the sign, which is plus, is twice the product of the first and the second term, which is 6x, twice of that, plus the square of our last term or second term, which is 6 squared. Therefore, the perfect square trinomial, or the expansion of perfect square binomial, would be x squared plus 12x plus 36. We can use this relationship to find the missing term. To make it a perfect square trinomial, that can be factored into a perfect square binomial. So if you would notice here, our middle term or second term is actually 12 divided by 2 equals 6, which is our second term of our perfect square binomial. And our last term here, which is 36, is actually 6 squared. That will give us 36, which is the last term as well of our perfect square binomial. Another example is if we have a perfect square trinomial. How do we factor a perfect square trinomial into a perfect square binomial? So what we did with the expansion, which is x squared plus 12x plus 36, when we factor this out, it will be exactly the same process. So we take the middle term, 18, we divide it by 2, that will be a 9. And when we square 9, that should give us the last term of the trinomial, which is 81. Therefore, the factor of x squared plus 18x plus 81 to a perfect square binomial would be x plus 9 brackets square. So how do we solve by completing the square? The first step is make one side a perfect square by adding a blank to both sides. So since this is not a perfect square, we will add a blank to both sides. So this would be x squared plus 12x plus, we place a blank, equals 0 plus another blank. The third step is to divide the middle term, which is 12x, by 2. So we have 12 divided by 2 would be 6. Then the next step is to square that answer. So 6 squared will be 36. So we add it on both sides, 36 and 36. Then we factor the left side of our equation. So the factor would be x plus 6 bracket square equals 36. The next step is to square root both sides. So take the square root. This will be x plus 6 equals plus minus 6. Then we transfer plus 6 on one side to find the value for x. So we have x equals negative 6 plus minus 6. Therefore, x can be negative 6 plus 6, which is 0, or x equals negative 6 minus 6, which is negative 12. Therefore, the possible values of x here to make this equation true is x can be 0 or negative 12. Another example. Again, we move the constant to the other side of the equation. So we have x squared plus 6x equals negative 8. After moving the constant to the other side, we add the blank on both sides. Plus the blank plus the blank. The next step is to divide the middle term by 2. So we have 6 divided by 2 is 3. And then we square that answer. 3 square is 9. Therefore, we will add 9 on both sides of the equation. The next step is to factor out the left side of the equation. So we have x plus, you just need to copy the quotient, which is 3, square equals negative 8 plus 1 plus 9 is 1. The next step is to take the square root. So we have x plus 3 equals plus minus 1. Therefore, the value of x could be, before we find the value of x, first is we have to transfer 3 on this side to the other side. So we have x equals negative 3 plus minus 1. Therefore, the values of x could be x equals negative 3 plus 1, which is negative 2, or x equals negative 3 minus 1, which is negative 4. Therefore, the possible values of x in the equation x squared plus 6x plus 8 to make this true, which is equal to 0, could be negative 2 or negative 4. Let's do another example. X squared plus 8x minus 84. What's the first step? That is right. We move the constant to the other side of the equation. So we have x squared plus 8x equals 84. Since it's negative here, when you transfer it becomes positive 84 or plus 84. The next step is to add a blank to both sides. Plus, plus. Then we divide the middle term by 2. 8 divided by 2 is 4. Then we square that answer. 4 square is 16. Then we add 16 on both sides of the equation. Once we have added 16, then we factor out x plus 4 square equals 100. Then we take the square root That will be x plus 4 equals plus minus 10. Then we transfer plus 4 to the other side of the equation to solve for x. So x equals negative 4 plus minus 10. Therefore, the possible values of x would be x equals negative 4 plus 10, which is 6, or x equals negative 4 minus 10, which is negative 14. Therefore, the possible values of x that will make this equation true, which is x squared plus 8x minus 84, would be positive 6 or negative 14. Now it's your turn. All right, so for the first given, the first step is to move the constant to the other side. So we have x squared minus 2x equals, since that's negative 15, it will be positive 15 when we move to the other side. Then we add a blank on both sides, plus, plus. Next step is to divide the middle term by 2. So 2 divided by 2 is 1, and then we square that number. 1 square is 1. Then we add on both sides that value. The next step is to factor out the left side. So this will be x minus 1 square. Why is it minus? That's because of the middle term's sign. That's why it's minus. Equals 16. Then we take the square root. That will be x minus 1 equals plus minus 4. Therefore, x is equal to, we move negative 1 to the other side, that's 1 when it's being transferred, plus minus 4. X is equal to 1 plus 4 is 5, or 1 minus 4, negative 3. The other example. What's the first step? Move the constant to the other side. So we have x squared plus 4x equals 10. And then we add blank on both sides. Plus, plus. The next step is to divide the middle term by 2. 4 divided by 2 is 2. Then we square that value. 2 square is 4. Then we add that value on both sides, 4 and 4. And then the next step is to factor out. X plus 2 square equals 14. Then we take the square root on both sides. That will be x plus 2 equals plus minus root of 14. We don't need to take it out from the square root. No need to make it into a decimal. Just leave it as plus minus root of 14 when the number is not perfect square. Then we transfer positive 2 to the other side, or plus 2. It will be negative 2 plus minus root 14. Therefore, the possible value of x would be negative 2 plus 14, or negative 2 minus root 14. Sorry, that should be square root. Okay, so negative 2 plus square root of 14, or negative 2 minus square root of 14. I hope you have learned something from our Maths Easy episode today, and I hope that you have learned how to use completing the square in finding a solution in an equation. And of course, for those that are new to my virtual classroom, please don't forget to click that subscribe button and notification bell for your attendance today. As Teacher Maria would always say, live your life to the fullest, learn something new every day, and love one another as how our God loves us. See you next episode for our Maths Easy series. Bye!